You know, mathematicians can be a pretty patient bunch. But there's this one particular cold case they've been working on for, just over 2,000 years. It's a mystery that has stumped some of the greatest minds in history, and it all revolves around a single number that, for a little while, managed to convince everyone it was something it wasn't. So let's open the case file.
It's a weird question, right? Can a number actually lie? We think of numbers as the bedrock of truth, the one thing that's always constant. But in this explainer, we're going to track down a mathematical imposter, a number that pretended to be something special, and honestly, it almost got away with it. This is a real-deal mathematical detective story.
And believe me, this hunt has been going on for a long time. It all started way back with the ancient Greeks, with guys like Euclid who first wrote down the rules of the game. Then, fast forward to the 1600s, and René Descartes stumbles upon a very promising, but as we'll see, very flawed clue. And even today, right now, we are throwing massive supercomputers at this same problem, searching for something that might not even exist.
So, what is it that we're actually hunting for? The official name for our target is a perfect number. Now, the definition sounds fancy, but it's actually pretty simple. You just take a number, find all the smaller numbers that divide into it evenly, those are its proper divisors, and then you add them all up. If that sum equals the original number you started with, then boom, it's perfect.
Let's just try it with a classic example, the number 6. Okay, so what are its proper divisors? Well, 1, 2, and 3 all divide evenly into 6. Now let's add them up. 1 plus 2 plus 3 equals 6. See? It's perfect. Which, I gotta say, feels like a lot of pressure for a single digit. I mean, I can barely get my coffee-to-water ratio right in the morning, and here's 6 just effortlessly perfect.
Now, here's where it gets interesting. When you start finding these perfect numbers, a weird pattern shows up. After 6, the next one is 28, then 496, then 8,128. You see it? They're all even. In fact, every single one of the 51 perfect numbers we've ever found is even. A brilliant mathematician named Euler even came up with a formula to find all of them. So the even ones? Yeah, that case is pretty much closed. Which leaves one huge glaring question. Where are the odd ones?
And this question brings us to the year 1638 and to the brilliant philosopher and mathematician René Descartes. You know, the I think therefore I am guy. He was deep into this mystery, and he was convinced he'd finally found a lead. He uncovered a number that looked, for all the world, like it was the very first odd perfect number. He finally had his prime suspect.
And there it is. Yeah, I'm not even going to try to say that out loud. But just look at it. For the first time in centuries, this was a real lead, a genuine suspect in the case of the missing odd perfect number. It was kind of like a mathematical Trojan horse. It looked perfect from the outside, it passed all the initial inspections. Descartes really thought he might have just closed this 2,000-year-old case.
Now, to test a number this massive, you need a special tool. It's called the sigma function. And don't let the Greek letters scare you off. It's super simple. All it does is add up all the divisors of a number, but this time you include the number itself. So here's the test. For a number to be perfect, the result from the sigma function has to be exactly double the original number. That's it. That's the whole test. So, Descartes took his gigantic number, and he ran the test. He fed it into the sigma function, and unbelievably, it worked. The math checked out. The function gave him back a value that was exactly double his number. By all accounts, it was perfect. The hunt was over.
Except it wasn't. The whole thing, the entire beautiful calculation that made this number look so special, it was all built on a shaky foundation. It was all built on one critical hidden lie.
And here it is. This is the crucial lie. Descartes' whole calculation only works because he assumed that one of its key building blocks, the number 22,021, was a prime number. But it's not. Turns out you can actually break it down into 19 times 19 times 61. It's what's called a composite number. And because it's composite, it has all these extra divisors that Descartes didn't know about. And once you add those into the sum, the whole thing gets thrown way off. The perfect calculation just completely unravels.
So yeah, this number was a total fraud, an imposter. I love this quote that describes it perfectly. It's the scientific equivalent of wearing a fake mustache to get into an R-rated movie. It looks the part until someone looks a little too closely at the glue.
Okay, so a 400-year-old number turned out to be a fake. It's a fun story for sure. But why are mathematicians still using supercomputers to look for odd perfect numbers? Why does this epic, seemingly fruitless search still matter to us today?
Well, for one, in math, a really smart guess just isn't good enough. You need cold, hard proof. But maybe more importantly, the tools we build to solve these really abstract problems often have incredible real-world uses. The advanced math about prime numbers that was developed during this long search, that's the very foundation of the encryption that protects your bank account, your private messages, everything you do online, every single day. Sometimes the search itself is what drives the real breakthroughs.
And that kind of leaves us with this final thought. Descartes' number hid there right in plain sight for centuries, pretending to be something it wasn't. It really makes you wonder, what other fundamental truths are we just taking for granted right now? What other mathematical liars are just sitting out there, waiting for someone to finally look a little too closely at the glue?